You are a crime scene investigator, and you've been called to a wooded area where a human body has been discovered. The remains have been identified as those of someone who has been reported missing. As part of the criminal investigation, it's up to you to determine the time of death. In this investigation, you will examine insects found at the scene to estimate the post-mortem interval, or PMI, the amount of time that has passed since the person died. Determining this will help to build a strong case against the prime suspect, who was last seen with the victim before he was reported missing. Here's your background information. Entomology is the study of insects. Forensic entomologists can study insect evidence at a crime scene involving someone's death to help determine the post-mortem interval, the time since the death occurred, and other clues about the circumstances surrounding the death. The life cycles of certain insect species are reliable at specific temperatures. Certain species of flies, such as blowflies, arrive almost immediately after the death of a human or animal to deposit eggs. When larvae emerge from the eggs, they feed upon the remains. After adults emerge, they leave behind the puparium casings that had covered the adults during the pupa stage. A forensic entomologist makes visual observations, collects insect evidence, determines the stages of development, and calculates the time of initial deposit of the eggs on the remains. In the laboratory, the scientist grows collected specimens to confirm the species and accurately determine the stage of growth. Based on the information they gather, they then calculate the post-mortem interval. Forensic evidence can be compared with eyewitness accounts, if there are any, and with testimony from possible suspects. The expert testimony of a forensic entomologist may also be presented during trial. So let's see what we have. An investigation notebook is where you put your observations. The adult fly, you're going to identify the species of fly. The fly larva, you're going to also identify the species. The fly pupae, you will also identify the species. And the pupa casing, that's where the adult fly came out of. This is an incubator. That's where you're going to grow the larva and the pupa until they become adults so that you can accurately identify them. And a hand lens, or a magnifying glass, which just magnifies things so you can see them better. We're going to open our lab notebook and review crime scene observations. The body was discovered on September 26th in a heavily wooded forest. That's important, heavily wooded forest in the Green Mountain region of southern Vermont. The body was on the ground and shaded by some trees, also important, causing it to receive little or no direct sunlight. The air temperature on the day the body was discovered was about 68.2 degrees Fahrenheit. The victim was first reported missing on September 1st. The average daily temperature of the region between September 1st and September 26th was 71.9 degrees Fahrenheit. See table 1 below for daily temperatures. It just gives all the temperatures, and the average temperature for the month was 71.9. The following insect evidence was gathered at the scene. There were adult flies, empty pupa casings, larvae, and pupae. It's not yet clear whether the evidence is from the same species of fly or from different species of fly. So what we're going to do is we're going to put these in order. So the first thing that happens is, we got from our background, larva. After larva, they turn into pupae. After pupae, you have, well, I guess you have an adult fly. And after you have an adult fly, they leave their pupa casings behind. Questions? Hopefully not. What we're going to do now is we're going to put our specimen bottles into our incubator. And we're going to try to grow some things. We're going to pay attention to how many days. 2 days. And what happened in 2 days? Specimen 2 changed from a larva to a pupa. So let's see what we have. Changed from larva to pupa. And how many days did we say it took? 2 days. But they want it in hours. So how many hours are in a day? 24. So 2 times 24 equals 48 hours. We are set. We're going to put them back in, see if we can grow some more things, see what else happens. Stick them both back in. 8 days. And in 8 days, in cup number 2, we went from pupa to fly. And that's the casing that it left behind. Let's record that. Change from pupa to adult. So the total time was 8 days. But that's the total time from larva to adult. We just want pupa to adult. So we're going to subtract out larva to pupa. So 8 days minus 2 days equals 6 days. We still want to multiply that by 24 because I want it in hours. So times 24 hours gives us, do a little math, and that's 144 hours. Good? We're going to put it back in and see if we can get a third cup to keep growing, because we want that to turn into adult flies. Hooray, adult flies. Okay, so this one says change from pupa to adult. These guys, number 3, started out as pupa. So the entire time from the beginning until now, we're going to use. And the entire time is 13 days. So we don't have to subtract anything. We have 13 days times, you guessed it, 24 hours equals, math people, 312 hours. Fabulous. Questions? Next, we're going to measure how long these guys are with a metric ruler. Now, the metric ruler, they set it up a little strange. What we do as scientists is we start from this mark here and go forward. What they did was they started from the 1 and kind of went backwards. So you're going to have to work with what we have. If they started from here and they went backwards, they ended right about here. So you're going to mark that down for number 1. For number 2, they started from 1 and ended right about somewhere in here. And for number 3, they started up here and they ended right about there, maybe a little further. And we're going to write that down in our lab notebook in the length. I'm not going to take the time to do that right now because you guys just did it. I'm just going to write dots. You can come back or pause it or rewind and see what the measurements are so you get your own. We're also going to look at quickly, oh no, we're not yet. Let's see. We're going to use our magnifying glass and we're going to look at the colors of the bodies. We're going to look if they're smooth or hairy. So that guy's definitely hairy, right? So we'll say number 3, definitely hairy. These guys are smooth. This guy is smooth. Now we're going to look at our field guide and see if we can figure out what they're called. No, we'll do the hairy guy first. Hairy guy is definitely not him. Definitely not him. Here we go. That guy looks hairy. He is called a blue bottle fly. And these are the stages. And this is the amount of time he spends at each stage. So let's see if we can enter some of that information in our notebook. We'll go back to data. So we said number 3 is a blue bottle fly. And if we looked at the color of him, what color is he? Like blue-gray, maybe? That works. Let's see if we can find 1 and 2. So let's see what they're not. If we go look here, look at the bottom one, the housefly, which are normal flies, they're found throughout the United States and Canada, but they are rarely attracted to corpses. So since our guys were definitely found on corpses, it's probably not that guy. So let's look at our other choice. This guy's our next one. He looks bright green, and our guys don't look very bright green. They're found in rural woodland areas, so that's good because our body was found in woodlands. But they're found in mostly open, well-lit areas. If you remember from our backgrounds, our body was found in the shade, so maybe not. Let's check our last one. Found throughout the United States and Canada, prefers cold climates, is only found in the deep south in winter, usually found in shaded areas, that works, and they're usually the first insects to lay eggs on a corpse. That works for us too. It kind of has the same colorings, right? This guy is kind of black and gray, this guy is kind of black and gray. So I would say, good guess. So let's say number 1. Black bottle fly. Let's look at number 2. He looks the same, just like a little smaller, right? So I would say he might just be a smaller black bottle fly. You can fill in the body color from the field guide. Like we said, black, gray, black and gray, whatever you want to put. You're going to put. And we'll put this away for now and see what we have next. Oh, we're going to do some calculations now. Let's see. Calculations. Write the name of each specimen. So the first one, we said this guy was a black bottle fly. Black bottle fly. And we're just going to copy this out, these numbers out from the field guide. So we go to the field guide, egg stage, 23 hours. Larva, 27 hours. Larva instar 2, 22 hours. So 23, 27, 22. 23, 27, 22. Back to the field guide. Instar 3, 130, and pupa 143. So 130, 143. Oops. 130, 143. And it totals it for us, so we don't have to do so much math, which is wonderful. Total is 345. Next, it tells us divide the total hours by 24, and that way we get the number of days. So 345 hours, nope, that's not right. 345 hours divided by 24 gives us 14.5 days. That's the number of days that have passed since the eggs were deposited on the body. Insect specimen 2, we also said was probably a black bottle fly. And then they say from table 2, how long did it take the larva to form pupa in the lab? So we have to look at table 2. That's table 3. Here we go. How long did it take the larva to form a pupa? 48 hours. We go back to calculations. 48 hours. Next, let's go down a little bit. Add the total of numbers from the egg stage to the end of the larva insta-3 stage. So let's see. Egg stage to larva insta-3. So we have 23 plus 27 plus 22 plus 130. 23 plus 27 plus 22 plus 130 equals 202. Subtract the number of hours that the larvae spent in the lab before they changed into pupae from the total number of hours between egg stage and larva stage. So this is total number of hours between egg stage and larva stage, 202, minus the total number of hours they spent in the lab. So that was 48 hours, and we get 154 hours. If we divide 154 hours divided by 24, we get 6.4 days. Since the larvae found at the crime scene were the offspring of the adults found at the crime scene, good, they're giving us information. We know they're both the same species because they're the offspring. You can find the total number of days that passed between when the body was first disposed and when it was discovered by adding the minimum number of days that have passed since the first generation eggs were deposited on the body, which is the number of days calculated for specimen 1, plus the number of days that passed between when the second generation of eggs were deposited and when they were discovered at the crime scene, which is the number of days calculated from specimen 2. So that is, well, we can see specimen 2 right here, so we'll write it here, 6.4, and now let's go up a bit so we can find the other one, 14.4. 14.4. So we found our PMI. We think our PMI is 20.8 days. Let's check it by using specimen 3. Specimen 3, we said, was a blue bottle fly. So this guy will have a little different numbers. We're going to use the field guide to fill this in. We need our hairy little guy. Come on, hairy guy. Here we go. We've got 28, 34, 28, 28, 34, 28. Then we've got 68, 290, 360. 68, 290, 360, which gives us a total of, what did I forget? 29, 34, 28, 68, 290, 360, a total of 808. Enter how many hours it took to change from pupa to adult in the lab from table 3. Let's find table 3. I think they mean table 2 because table 3 is just characteristics. So to change from pupa to adult, it took 312 hours. So it took 312 hours. Subtract the number of hours it took the pupa to change to an adult in the lab from the total number of hours it would take for an adult to emerge after an egg is deposited. So, total number of hours would be 808 minus what happened in the lab, which was 312. We get 496 hours. Now, if we divide that by 24, 496, we get 20.7 days, which is pretty close to what we got up here, which was 20.8 days. Right? Great. Let's see what we're going to do next. Next is our conclusion. So let's look at these calculations one more time slowly so you can fill them in if you need them for your data. So your PMI is right here for your species 1 and 2. And then for your species 3, your PMI is right here. Now we can do our analysis and conclusion. If the body was discovered on September 26th, right, so it was discovered on September 26th, the PMI that we determined, that was the time since death, so the PMI was about 20.7 or 20.8. We have to figure out what day the victim's body was left in the woods. So if it was found on the 26th and we figured out the PMI, which is the amount of time since he died, was 20.7, so a little more than 20 days, what's the date that he was probably left there? Next question is, what do you think came out of that empty puparium found at the scene? Then, why do you think temperature is important? Explain whether or not temperature would have greatly affected the outcome of the case. So if it said it was about 70 degrees, if it were 32 degrees, what do you think would have been different? And if it were 98 degrees, what do you think would have been different? Lastly, predict how might the insect evidence have been different if the body was disposed of in a well-lit area. Refer to the field guide. So let's look at the field guide and look for well-lit. Start at the top. Found in the deep south, usually found in shaded areas. So shaded areas says nothing about well-lit. That's not going to help us very much. Found in rural woodlands and mostly in open, well-lit areas. So if it was found in a well-lit area, this might help you. Let's see if anything else is of interest. Found throughout the United States. Doesn't say anything about lit or not lit. Doesn't say anything about lit or not lit, just says it's not really attracted to corpses. So you're going to come up with a prediction based on your field guide. You're going to put all those answers into your document, and you are finished with your lab. If you need to go backwards, just rewind and pause, and you're done. Congratulations.